All right, so we continue with our topics, the week 3 topic, still on approximation and percentage error. So we'll be looking at error in approximation. Error can be defined as the half of the smallest value of the approximation. The smallest value of the approximation depends on the level of approximation. Like for example, if you are dealing with decimal places, let's assume that you approximate a value to one decimal place. Like for example, now 2.7 is into one decimal place, 18.5 is into one decimal place, 7.3 is into one decimal place, and so on. The smallest value is going to be 0.1. That is the smallest value. So if the smallest value is 0.1, you can use that to calculate your error. So the error is going to be 1 over 2 times this is 0.1, which is the smallest value of the approximation. Like for also another example is that in case if the number is into two decimal places, for example, 1.56, 1.56, 85.94, 3.67, and so on and so forth. So the smallest value is going to be 0.01. This is going to be the smallest value. The same thing if it is into three decimal places, such as 1.568, 85.947, 3.468, and so on and so forth. The smallest value is going to be 0.001. That's the smallest value. So for each of the approximation, you can estimate your error by saying 1 over 2 times that smallest value. If the smallest value is 0.1, it's going to be 1 over 2 times 0.1. If the smallest value is 0.01, the error is going to be 1 over 2 times 0.01. The same is significant figure. For example, let's assume that we want to approximate 6,400, 6400 to one significant figure. That is, you count the first number, which is 1, then the other number becomes 0, since 4 cannot approximate 6. So you are going to have 600. This is one significant figure. Here, the smallest value is going to be 1,000. That is the smallest value. It's going to be 1,000. That is going to be the smallest value. We can also decide to approximate this number to two significant figures. That will be 6,400 to two significant figure, and the smallest number is going to be 100. You can also approximate to three significant figure, which the answer still remains the same. This into three significant figure, and here the smallest value is going to be 10. And if you are to approximate to four significant figure, the smallest value is going to be 1. So each of the smallest value can be substituted here, then you can estimate your error. Now, another level of approximation is if you are to approximate to the nearest unit. For example, you want to approximate to the nearest centimeter, to the nearest meter, to the nearest kilometer, and so on. The smallest value of such approximation to the nearest whole number is 1. That is the level, that is the smallest value. With that, you can then estimate your error. Let's look at a particular example of what I'm trying to say. Example 1. If the distance from a school to the market is given as 9.8 kilometers to one decimal place. This is an example of decimal places now, to one decimal place. What is the percentage error in the approximation, and also calculate the range of the measurement. Now let's look at the solution. Firstly, you need to know the actual value. The actual value given to us is 9.8 kilometers. This is the actual value. Since it's into one decimal place, we know the smallest value of one decimal place. The smallest value is going to be what? 0.1. Since it's into one decimal place, 0.1 is the smallest value. Therefore, we can calculate the error. So the error now is going to be 1 over 2 times the smallest value of approximation, which means it's going to be 1 over 2 times 0.1, which will give us 0.05. So 0.05 is the error. With this, we can then estimate the percentage error. So the percentage error is equals to the error divided by the actual value times 100 over 1. So this is the formula that you can use to calculate the percentage error. In this question now, we know what the error is. The error is 0.05. So 0.05 is the error divided by the actual value. The actual value was the value given for us from the question, 9.8, then times 100 over 1. When you calculate this, you should get 0.51%. This is the percentage error. That is the first question. The first question is to calculate the percentage error in the approximation. The second question now is to calculate the range. So the range now, the range is equals to the actual value given to us, then plus or minus the error. This will give us the range. That is, the actual value is 9.8, then plus or minus 0.05, which is the error. Meaning that the range now, 9.8 minus 0.05 is going to give us 9.75 kilometer. So by the time you add 0.05 to 9.8, it's going to give us 9.85 kilometer. That means the range of the distance is between 9.75 kilometer to 9.85 kilometer. So this is how to make use of the errors in approximation based on the calculation given to us. So in our next class, we are going to be looking at the second example on this. Thank you so much.